as we planned at the beginning of this particular course, we said that we will do it in about 4 stages. The stage 1, we will do the foundation. So wherein we speak about the high school and a little bit of the college stuff, so at the foundation level, and we get complete grip over what we have been doing and what has been expected, right? So to know before we go on to the intermediate stage. Intermediate foundation stage will ensure that we can score about 80 percentile in CAT or maybe more than that, right? So if you are clearly understanding it, we can expect even a result more than 80 percentile CAT. And intermediate level will ensure that we reach somewhere from 80 to 95, right? So that is what the intermediate level does, which will take about 2.5 to 3 months, right? Because that's the most critical stage, because it will take us the journey from 80 to 95. Then we'll go on to the advanced stage of learning, wherein we will pitch ourselves between 95 to 100%. And the revisions are very important, because by the time we do this particular journey, naturally we would not remember all of it, but the reinforcement will help us to recall some of the important concepts, some of the important methods, some of the important approaches. Right? That's the journey bin. And sure, we will start with the LRDI, especially the DIs, once we are through with the foundation part of the journey. Simple reason being, when we do the DI, the primary parameters are if our understanding of percentages, profit loss, and discounts, or it could be ratios and the averages. Once these concepts are clear, it becomes a lot more easier to deal with the DIs, right? Yeah, so that's been our understanding so far, and let's continue this journey. So let me quickly give a quick background to you guys as we go along. Yes, so before that, let me quickly introduce myself. Here I am, Belvi Srinivas. I've been working in the test prep industry for the last 14 years, that is since 2007, and I worked in various capacities, as you can see from this particular deck. Yes, I worked both on the management side of it and also on the training side of it. At the training front, I trained the students in the areas of QA, DI, and I developed sufficient understanding of counseling the students to reach their. That's briefly about me. And how do you reach out to me? You can reach out to me by using these Telegram channels, one of these 2 Telegram channels. If you have any short concerns or the doubts that you would like to resolve, or you have some short questions that you need a quick response to, you can reach out to me on this particular Telegram. You can use any of these, one of these Telegram. Yeah, and let me start with a quick announcements before we unleash ourselves into the journey on factors that we started yesterday. So here is the Ask a Doctor feature on the Unacademy app. So if you have downloaded the app, be it a desktop app, or be it a mobile app, doesn't matter. If you have, there will be a feature on your dashboard called as Ask a Doubt. And the ask a doubt feature, certainly, right, you can ask about 3 doubts at once, right? 3 doubts at once, you can kind of ask it. Once they are addressed, then you can ask few more doubts and so on, right? And therefore, if it's not getting reflected, just in case you are thinking that no, I'm not finding this particular feature, ask a doubt feature, you might have to refresh that particular app, or again reinstall that particular app, so that all the new features would appear on your dashboard, right? That's how you can get your doubts rectified. In addition to the Telegram channels, in Telegram channels also there are enough peers who are trying to address it, or the faculty members might address it. Nevertheless, already there is a doubt feature as well, and it can be addressed in your language of your own. In case the English is not comfortable, you want to get that response in your mother tongue, already in your own language, there is a feature there. You can suggest which language you want to get that response, so that response could be given in that language as well. Yeah, just in case if you have taken the CAT 2021, if anybody here, those who have taken a CAT 2021, you can register yourself for MBA championship. And if you register there, if based on your CAT scores, if you have done really well in your CAT course, you will be rewarded with 10 times of your subscription feedback, right? Feedback facility you will be getting. Because of your good CAT score, you will also be getting 10 times of feedback facility, something like that, right? That's a feature there, up to 10 times. So you can also kind of register for this MBA championship. All right, so that sets us to the discussion from where we kind of stopped yesterday. Yesterday, I think we started off our journey with the factors, and we were learning a little bit about the factors. We will continue our journey with the factors basics, what we learned. Technically, as I told you, that the factors start in the class 4. Class 4 is when you come in contact with the factors for the first time. You study about the factors. From there, the journey continues and continues and continues. Right? Yeah. So here we go. So let's continue. Let me quickly put it to the perspective. I told you that, hey, if there is a number, so when you look at the factors, the number of factors less than the root of the number would be same as the number of factors more than root of the number. That's one of the points that we discussed. If there are x factors less than the root of the number, there would be x factors which will be more than the root of that particular number. X factors would be more than root of that number. Then we talked about the second point that we talked about was, so if the given number n is not a perfect square, then n would have even number of factors, which means it can have 2 factors, 4 factors, 6 factors, 8 factors, and so on. Right? If the given number n is a perfect square, if it is a perfect square, given number n is a perfect square, then it would have odd number of factors, which means it can have 1 factor or 3 factors, 5 or 7, and so on. Right? This is what it has. And under this, we also talked about few things. Hey, if this n looks like a square of a composite number, if the n is a square of a composite number, then it would have more than 3 factors, that is 5 or 7 or 9 or 11 kind of. Right? If given number n is a square of a prime number, n can be represented as a square of a prime number, then we said that it would have exactly 3 factors. We went on to give some examples there. For the first one, 18 can be a kind of example. 18 is a number which is not a perfect square. Then we found out the factors for it. Then here, all right, now number could be 36. 36 can be a number. Here, all right, this particular case, we took 25. These were some of the things that we kind of discussed. Then towards the end, fag end of that, we also discussed that if there is a composite number n, then we said that we apply the fundamental principle of arithmetic on n. Thereby the n looks like prime 1 raised to power a, prime 2, that is resolving the given composite number into primes, right? Prime 3 raised to power c, and so on. When you write this, then we said that okay, therefore number of factors of n, could be represented as a plus 1. I explained it why it should be like that, right? By FPC, fundamental principle of counting, we made use of that to understand this. A plus 1, b plus 1, c plus 1, etc. Right? That is how we figured it out. Now what we do here is we will continue our journey from here. Let us look at some of the applications of this. Let's go a little deeper into this. We did one kind of question in yesterday's lecture. We will take a recap of that particular question, then we will continue our journey from here. All right, let's take a look at this. What does it say? Let the number n be. This was the question which I did yesterday, right? Yesterday, let me quickly recap this. That helps us. Hey, we have 7,200. I told you how to write this quickly there. 7,200, we said that this can be written as 2 raised to power 5 and 3 square and 5 square, right? 7,200 can be written as 2 raised to power 5. Once you resolve it into primes, it appears like 2 raised to power 5, 3 square and 5 square. That is my 7,200. Then we said that, hey, how many factors are there for this particular number? We presented by saying that the factors, total number of factors of 7,200 are 6 into 3 into 3, right? So therefore you said that it is nothing but 54 factors. The given number has 54 factors in total, right? Yeah. Then we said that how many prime factors are there for this number? We said it is only 3, right? There are only 3 prime factors. Which are those 3 prime factors? 2 is a prime factor, 3 is a prime factor, and 5 is a prime factor. It is 2, 3 and 5. When it comes to composite, we said that it is 50. Why 50? So 50 because out of the total, 1 is not a prime, 2 is not a prime, 3 is not a prime, and 5 is not a prime factor, right? Because we already observed that 2 is one of the prime factors, 3 is one of the prime factors, right? 3 is one of the prime factors and 5 is another prime factors. Along with that, 1 is neither prime nor composite. Remove these 4 out of the total of 54. The rest are composite factors, Right, fair enough. So that is what we kind of discussed till yesterday. So now we'll get on to our journey. Now before we go, let me quickly make certain announcements and then we will get on to today's journey. Right, yeah. So on 29th of December, that's come tomorrow. So you have a new batch launch called as a percentiler batch. Right, they start from basics. You want to know about clear objectives of this particular batch, because every batch has an objective. On the Unacademy platform, generally you find about couple of batches starting every single week. Right, reason being there are different learners who want to learn differently at a different depth, etc. So the batch which is starting here is termed as a basic batch. If you want to understand exact objectives of this, each of these educators would have made a short video of 3 to 5 minutes. Please take a listen to that particular video of 3 to 5 minutes. You will understand how they want to approach this particular course in that particular given month. Right, that's how you understand. It's a pretty structured course. Some of the batches start at the basic level, some of the batches start at the intermediate level, some of the batches start at the practice level, differently. Right, every batch has a different objective there. What suits you, you got to follow that particular batch. You can follow multiple batches. Right, on RC, on the verbal, you can follow a basic batch. Maybe on Quant, you can follow an intermediate batch, which means the teaching is at the intermediate level, or whatever suits your requirement, how confident you feel about each area of your preparation. Right, fair enough. So all this comes at a nominal subscription fees, because these are called as the plus batches. All these structured batches are termed as plus batches. Right, so there are multiple subscription plans: 6 months plan, 12 months plan, 18 months plan, and 24 months plan. Multiple subscription plan. Now each plan has a different subscription fees. Now these are the subscription fees. On the subscription fees, yes, you do get 10% discount whenever you use any of the educator code. On every plan you get 10% discount whenever you use any educator plan, including my code, which is Belvi 100. It suggests Belvi 100, but you still get only 10% discount. Right, yeah. So that's about the plus, but my preference is very, very clearly the iconic. There are two types of subscription plans. One is the plus, as I told before, and this is the iconic subscription plan. Now iconic plan, you get one-to-one interactions. In a 6 months iconic plan, you get 25 one-to-one interactions. If it is an annual iconic plan, you get 50 one-to-one interactions. Who sets up these one-to-one interactions? It's you who can set up these one-to-one interactions. Right, yeah. So with agenda, in the sense you can set up this agenda with the educator of your choice. You can set up this. A 6 months is technically 26 weeks, but you get about 25 one-to-ones there, which implies that every week you can have a meeting with a mentor of your choice. What can be discussed? Anything, all right, anything from your prep calendar. You want to plan your preparation based on your strengths and weaknesses and the available time, etc. You can plan from there, and then from the when the tests appear, you can plan your test strategies along with the mentor. So you test improvements, you can plan filling the application forms, you can do along with the mentor. You can use this window of 25 sittings, 25 one-to-one sittings with the mentor in many different ways, right, including your doubt solving, including your concept discussion. Some concept is not clear, some RC is not clear, I want to sit with the faculty member and want to understand that. Yeah, even that can be done there. Right, so therefore my preference is clearly iconic subscription, because discussing with the mentor on a regular basis will ensure that you are moving in the right direction. Your motivation levels are very high, because in the offline classroom this is what does happen, because you every time see a mentor, and whenever you want to have a small chat, you can always have a small chat. Here you may have to you may have to kind of connect with the subscription to ensure that, okay, a week on week you are kind of meeting the mentor, speaking to the mentor. Yeah, that's very important there. Yeah, so on this as well, you get 10% discount whenever you use any of the educator code, including my code, which is Belvi 100. On all these plans you get 10% discount, whichever the plan that you are moving for. Yeah, but as of now there is some offer. Just now I said that if you buy a 6 months iconic plan, you get 25 one-to-ones, but now there is an offer wherein you get 35 one-to-ones. If you buy an annual plan, 12 months plan, instead of 50 you are getting 70. In the sense, hey, a year, 12 months has 52 weeks, right, 52 weeks, but you can get 70 one-to-one sittings. In the sense, you can get more than one discussion with the mentor per week, right, which is a very welcome thought. So you can think about this plans. Yeah, so that brings me to the closure of the announcements. Let us now get on to the discussion for the day. So here comes. We already talked about this. Hey, what is this 7200? We spoke about this. We said that when I apply FPA on this fundamental theorem of arithmetic or fundamental principle of arithmetic, whatever you call this as, some people call this as FTA, fundamental theorem of arithmetic. Some people call this as fundamental principle of arithmetic. Doesn't matter what name you give. 7200 is nothing but, just now as we discussed, it is 2 raised to power 5. Then you say this is 3 raised to power 2 and 5 raised to power 2. Okay, we said that already. We said that how many factors for this particular number? 54. Total number of factors are 54. So much of information we kind of already had about this. But the question is, what is this question trying to ask me? It is saying that, hey, why don't you find the number of even factors of this particular number? In the sense, say, when you wrote all the factors, see, when I said that there are 54 factors, is 1 a factor of this number? Yes. Is 2 a factor of which number? This number, right? Is 1 a factor of this number? Yes, that's the smallest factor. Is 2 a factor of number? Yes. Is 3 a factor? Yes. Is 4 a factor? Yes. Is 5 a factor? Yes. Is 6 a factor? Yes. Is 7 a factor? No. Is 8 a factor? Yes. Is 9 a factor? Yes. Is 10 a factor? Yes. Like this, you went on to list these 54 factors. But author says, look man, out of these factors that you mentioned here, so I am not in favor of 1. I am not in favor of 3. I am not in favor of 5. I am not in favor of 9, right? Because he says that I clearly need even factors this time. I am not in favor of odd factors, right? That has been the message by the author. Fair enough. So if that is the case, how do I go about this? There are two ways to go about it. Let us discuss both the ways. One is an indirect way, right? One is the indirect way. The other one is a direct way, pretty direct way. Okay, let's say, what is the indirect way? Indirect way is, you know that total is 54, which means to do this particular question, the number of even factors is nothing but total number of factors minus the factors which are odd factors. Total factors minus odd factors will give me the even factors. That is one way of approaching, which generally most of the people do as well, right? But then yeah, there is another way as well which we should know, because that will help us to solve the remaining questions. Right. So how do I go about this? Simple. Now listen to me. So here yesterday we said that, hey, what do you mean by 2 raised to power 5? There are 5 cards on which 2 would be printed. Something like, okay, there is a 5 cards. 2, so first card, second card, third card, fourth card and fifth card. There would be 2 cards on which 3 would be printed, right? And there would be another 2 cards on which 5 would be printed. So that is what we kind of said yesterday, right? We kind of said that, okay, on the cards we'll kind of print it out here. Then from here you said that, hey, if you want, all right, if you want to form the odd factors, because I'm forming odd factors, because total is already 54 minus, I'm now forming the odd factors. If you want to form the odd factors, you got to ensure that these 2's are not used, because 2 into anything becomes even. So therefore you say that, hey, these 2's you keep it out. Let's keep this out, these particular 2's. Let me use only these 3's. Say, how many ways you can deal with 2 3's? Yesterday we discussed that we can deal it in 3 ways. What is that 3 ways? No 3 or 1 3 or 2 3, right? Okay, now how many ways I can deal with 2 5's here? Again, I can deal it in 3 ways. What is that? I will give no 5, or I will give 1 5, or I will give 2 5, right? Therefore 3 ways. Therefore what is my answer? 3 into 3, which becomes 9. You are trying to say that 9 factors are odd. Out of 54 factors, 9 factors are odd, which implies remaining 45 factors are even. Remaining 45 factors are even. Okay, this is one schematic way of looking at this. Hey, what is the quick mathematical way of looking at this particular one? Hey, you had this particular number. 7200 is equal to 2 raised to power 5 and 3 raised to power 2 and 5 raised to power 2, right? We had this particular number. If, let now here, even I want the odd, I'm again finding the odd factors. Listen to me, odd factors. If I want to find the odd factors, now from this I will write the active sample size. What do you mean by active sample size? This 2 power 5 I will not use. In the sense, I don't use any of these 2's. I won't use them. Active, I use this 3 power 2. I use this 5 power 2, because odd factors are generated by using the odd numbers only, because even number into odd number becomes an even number, right? Odd number into odd number is always an odd number. Therefore I have to generate by using only odd numbers. This was my total sample size. 2 raised to power 5 into 3 raised to power 2 into 5 raised to power 2 is my total sample size. Out of the total sample size, I would say that, hey, what is not in my favor? The 2 power 5 is not in my favor, because they're even terms. What is in my favor? 3 raised to power 5 into 5 raised to power 2 is in my favor, right? So let me use that. Therefore how do I use it? So, and hence you look at this, you say that, hey, this 2 2 can be permuted in 3 ways. This 2 can be permuted in 3 ways. 3 into 3, 9. That is mathematical way of looking at this particular number. That's what you wrote it as 9. Out of the total of 54, you subtract 9, remaining 45 or even. Okay, this is the indirect way of looking at this. In the sense, I need to know my total. From there, I remove the odd numbers, odd factors. From there, I will get my even factors. What is the direct way of looking at this particular question then? Direct way of looking could look something like this. Now, let us take a look at this. How do I go about looking at directly? Look, if you want an even factor, so there should be 2 always with you, and hence I will say that I keep a 2 out. Always keep a 2 out. 1, 2, I will keep it out. Out of 5 2's here, I am looking at 5 2's. 1, 2 is permanent. I want it to be there because 2 into anything is going to be even. Therefore, I do keep a 2 outside. Therefore, inside what I will have 2 raised to power 4. I am adjusting the sample size. 2 raised to power 4, this 3 raised to power 2 as it is, and this 5 raised to power 2 as it is. In the sense, out of this 2 power 5, I am saying that a 1, 2, you keep it out, which means it's a permanent for this particular question because I'm directly finding even factors. 2 into whatever you pick from the active sample size is going to be even. Therefore, I keep my 2 outside and keep the remaining thing in the active space, right? Active space. Now, what does it mean to us is this, right? This 2 is dealt in one way. What do you mean by one way? This 2 must be there because 2 into anything will be even. Even if you give a 3 from here, 3 into 2 becomes 6, right? Therefore, that is the 2 has to be kept out there. Now, you can permute this. This 4 can be permuted in 5 ways. See here, don't look at this 1 and it can be permuted in 2 ways. What do you mean by this 1 can be permuted in 2 ways? Which means either I can use this 2 or I cannot use the 2. But you don't have a choice of not using the 2. You must use the 2. That is the decision that we have taken. Keep the 2 out. This 4 can be permuted in 5 ways. This 2 can be permuted in 3 ways. And this 2 can be permuted in 3 ways. Multiply these particular numbers. It is directly 45. This is the direct way of dealing with the even number of factors. When they say that even means what? A multiple of 2. Hey, how many factors are multiples of 2? Or how many factors are divisible by 2? Both are same. So when you want the even number of factors, keep a card on which 2 is printed outside. Alright, now for here, if you go back to this particular premise, alright, you would kind of say that, okay, keep a card on which 2 is printed outside. 1, 2, you take it out. Rest of it, or you can permute it. You can play with the rest of the cards by keeping this 1, 2 outside. That is the meaning of this. I hope you got this particular perspective. If you have understood this, why don't you answer the next question, question number 5. I will give you about 10-15 seconds. Just quickly think about it. How do you go about question number 5? 5 here, factors divisible by 6. The factors which are divisible by 6. Yeah. All right. So that's how you go about it. Similar to the previous question. Factors divisible by 6. Factors divisible by 6. You 7,200. Mathematical way of looking at this. 7,200. You say that the total sample size looks like 2 raised to power 5, 3 raised to power 2, and 5 raised to power 2. If you want a 6, what is the 6? 6 is nothing but a 2 and a 3 because you don't have a number called as 6 here because it's a prime wallet represented in terms of prime factorization. So 6 is nothing but a 2 into 3. So therefore you say that all right, I will keep a 2 outside and I will keep a 3 outside. Then what is my sample size? Out of 2 raised to power 5, if you keep 1, 2 outside, you are left with 2 raised to power 4 as an active sample size. Similarly, out of 3 raised to power 2, if you keep one 3 outside, you are left with one more 3 as an active sample size and 5 raised to power 2. Okay, now what about this? This has to be dealt in one way. Why this has to be dealt in one way? For a simple reason that I want every number to be a multiple of 6. If you want every number to be divisible by 6 or a multiple of 6, you ensure that you kind of keep a 6 outside. You keep a 6 outside. That ensures that it can be dealt like that. Okay, now permute the others. This 4 can be now permuted in, or you take a look at this 4. This 4 can be now permuted in 5 ways. This 1 can be permuted in 2 ways. This 2 can be permuted in 3 ways, right? This is what you do there. And hence you say that, hey, this is nothing but 30. This is nothing but 30. You say that, hey, there are 30 factors which are divisible by 6. There are 30 factors out of 54 factors. Together we said that there are 54 factors for this number, out of which 30 of them are divisible by 6, right? Good. So that's about this particular question. Let's move further. Let's move further into this. I hope you are getting the perspective on this. So here comes the next one. Here comes the next one. I'll give just about 30 seconds. Why don't you think about this? How do you approach this particular question? Go ahead, my friends, try and think about this. Try and think about this. How do you approach this particular question? Yeah, good. All right. Let the number be number n. Same number, same number. There is no change in the number. Number is same. We are taken the same number there. We are just creating different types of questions so that we understand how to deal with the factors. That is technically the subset, right? The superset, we know. What is the superset? The superset is 2 raised to power 5 and 3 raised to power 2 and 5 raised to power 2. This is the superset. But for my questions, we technically need the subset. So what did we say here? Not divisible by 12. What is the best way to find not divisible by 12? Hey, total number of factors, total factors minus factors divisible by 12. Factors, right, minus factors divisible by 12. Alright, total number of factors minus the factors divisible by 12. That could be a nicer way to deal with this. Total number of factors minus factors divisible by 12 will give me the factors not divisible by 12, because there is no direct way to find for a negative number here. Not divisible is the question. Good. So let the total number of factors, cache memory, we already know that it is 54. Previous question we did. Alright, so we kind of know that, okay, this number is nothing but 54. Factors divisible by 12. How do I go about factors divisible by 12? Write the subset to start with. In the sense, hey, this is my superset. So I need to first pull out a 12. What is a 12 here, by the way? A 12 is nothing but 2 raised to power 2 into 3 raised to power 1. Do that from here. From here I will take 2 raised to power 2 out. From here I will take 3 raised to power 1. So what did I do by doing this? I took a 12 outside. Once you take a 12 outside, the rest of it you can deal it actively. Out of 2 power 2 you took it out. Therefore what is it remaining now? 2 raised to power 3. Okay. 3 power 1 is taken out. Therefore what is remaining now? Another 3 power 1. Right. 5 power 2 you would be representing directly as it is, right? Okay, so therefore this entire thing is dealt in one way because you don't have a choice. You want a number to be divisible by 12 or a multiple of 12. You don't have a choice there, 1. But here you can permute rest of the parameter. Rest of the elements can be permuted. This 3 can be permuted in 4 ways. This can be permuted in 2 ways, and this can be permuted in another 3 ways, right? Therefore you say that this is nothing but 24. Out of 54, 24 numbers are divisible by 12. Therefore the difference, right? Therefore the difference, which is 30, are not divisible by 12. That's the answer to the 6th question, right? How many factors of 7200 are not divisible by 12? You are trying to communicate that 30 of the factors are not divisible by 12, right? That's a point you are trying to make there. I hope by now you would have gotten into the groove, right? You would have started understanding that, okay, how I need to follow on this. There is a superset, right? You understand that once you look at the number, right? Once you kind of look at the number, you would have a superset. From the superset, you need to understand the active set, which is a subset there. Some of them would be passive. For example, one way means what? Mandatory. One way is passive, and the rest of it is active, which contributes. The passive and the active side you need to separate and start dealing with that. That's important there. Good. All right. So that brings us to the next question. Sets up for the next question. Yeah, try this particular question, my friends. Try this particular question. Why don't you try this particular question? I'll give you about 30 seconds. Think about it and try and work through. Yeah, okay. Now let me come back to the way I used to put this present this before. Present this before. What I meant is this. Okay, 7,200. You said that this is 2 raised to power 5, 3 raised to power 2, and 5 raised to power 2. Okay, what is 2 raised to power 5? Take 5 cards and print 2 on it. Take 2 cards, print 3 on it. Take 2 cards, print 5 on it. Right, this is what you mean by this. Now, since I want the factors to be perfect squares, in the sense you cannot give me 1 2. If you give me 1 2, and then even if you give me 3 square, all right, now assume that okay, I give both the cards on which 3 is printed, but you give only one card on which 2 is printed. Hey, this is nothing but 18. 18 is not a square perfect. 18 is not a factor which is a perfect square. Instead, either you give me 2 2s. If you give me 2 2s and 2 3s, then you are trying to say that 36. 36 is a perfect square. In the sense, when you give me the 2s and 3s, give me in pairs. So how do I do that? So you go back, alright, you go back to your matrix. You say that okay, let me put 2 2s together and bundle it as one. Right, that is 1 unit. What do you mean? 2 into 2, 4. Now let me take another 2 2s and bundle it as 1, which means whenever you are presenting, you are saying that this is one bundle and this is my second bundle. There are 2 bundles of 2s. Right, what about this particular 2? Can't use it. I can't use it because there is no a pair for it, because 2 2s I need to use at a time, because if I want a perfect square, take 2 2s together and pair it as 1. Now same thing you do it on the 3s. Same thing you do it on the 3s, pair it as one bundle, right? Same thing you do it on the 5s, pair this as another one bundle. Now if you got to use this bundle together, don't give me 1 2. If you are giving this bundle, it becomes a perfect square. Along with this, you are giving this bundle, it becomes a perfect square, because elements in every bundle are 2, right? 2 into 2 or 3 into 3 or 5 into 5, in the sense the elements are double there, so therefore it is always going to be a perfect square. The product, it's going to be a perfect square. And hence, how do you represent this particular thought? You say that hey, from here you rewrite this. Hey, what is this? 2 into 2? 2 square. 2 into 2, 2 square. How many bundles of 2 squares I have? 2 bundles, 1 and 2. I have 2 bundles of 2 square. You may wonder, sir, it is 2 power 5, but when you write it like this, it is becoming 2 power 4. That's what I explained, right? 1 2 cannot be used. All right, there is always that 1 2 which cannot be used, because you need to make it a perfect square, and hence inside the bracket you wrote a perfect square. You have 2 such bundles. Now similarly, how do I use this 3 square? You say that okay, 3 square is one bundle. There is only one bundle of 3 square, which I showed it to you already, right? 5 square here, right? 5 square. You got to take perfect square, because the word is a perfect square. Ensure that inside the bracket, instead of having a prime, you have a prime square inside. Hey, how many such bundles? One bundle. Now apply fundamental principle of counting on this. Hey, this 2 can be dealt. This is the active sample size. This is active. Alright, this was total. This underlined one is total. This is active. Why? From total to active, you could not use one particular 2 there. That is the difference, right? Total sample size is different. The active sample size is different. Now you are using the active sample size. Okay. So now this 2 can be used in how many ways? 3 ways, because this is a 2 square entity, perfect square entity. But this 2 can be used in 3 ways. Okay. There is one entity of 3 square. It can be used in 2 ways. There is one entity of 5 square which can be used in 2 ways. And hence you say that hey, this is nothing but 12. There are 12 factors which are also perfect squares. I hope by now you would have understood that okay, how do I work with perfect squares, or even if the question asks for a perfect cubes, all right, based on the numbers available, we know that how to understand them. Divisible by 12 means what I should do, divisible by 18 means what I should do, not divisible by 24 means what I should do, which means factors not divisible by 24, right? Like this. So if you know, by now you should have understood that okay, how do I deal with the total sample size versus versus active sample size and passive sample size, right? So there is going to be a total sample size. Questions need not be asked right on the total sample size. They want us to create a subset from there, the active sample size. From the total, create the active sample size, work on the active sample size. That is what could be expected from us, right? Yeah, that's that. By now you could have kind of gotten into the groove and you started understanding what is this whole factors formula is trying to do there. Technically it's a formula, isn't it? So you said that a number of factors is nothing but prime raised to power a, second prime raised to the power b, and there could be another prime raised to the power c, and so on. We understood that how to find the factors of this, but it's not going to be always using the entire sample size. We may use sometimes the active sample size, and from there we may have to figure out the answers, count the factors. Now that's about the counting business. Okay, from this counting, are there anything else that I can do from this counting? Of course, yes. All right, we'll talk about it. There are two other subset kind of questions which comes from this particular counting. But is the counting over here? No, this counting is just the high school revision what I did, right? Or some of you might have done in the 11th standard also. Doesn't matter where you did. It's a kind of a revision from there. That's it. Saying that, okay, we now understood that how do I quickly count the factors, but we have not gotten into the application level, which is the intermediate level, which we will go there in the next stage of our preparation. But before that, there are another two things that you might have to be mindful about. Yeah, what are those two things? Yeah, what are the other two things that you need to be mindful about? One, writing the number as a product of two factors. Take a look at this question. In how many ways 360 can be written as a product of two factors? Now think about this, my friends. Think about this. Let me take a simple example. Duck this particular question. Let me take a simple example to illustrate this particular point. To start with, let us take a number called as 72. Let's take a number called as 72. Say that instead of 360, I took 72. How many ways 72 can be written as a product of two factors? What did we discuss there? We said that the number of factors, all right, 72, the number of factors less than root of 72 would be same as the number of factors more than root of 72. Now let me write the number of factors less than root of 72. Let me list out in this particular column. Number of factors less than root of 72. Root of 72 is what? Approximately 8 point something, right? 8.4, 8.5. Fair enough. So let's write that. What are the factors there? 1 divides 72, 2 divides 72, 3 divides 72, 4 divides 72, 5 does not divide 72, 6 divides 72, 7 does not divide 72, 8 divides 72. Stop it, because 8.x. You don't have to write 9 under this particular column, right? I don't have to write 9 under this column. Now the second side, how do I write? Factors greater than root of 72. Factors greater than root of 72. Two columns. I'm writing the factors in two columns, right? So yesterday I wrote it like this, root 72. I wrote the factors less than root 72 this side and more than root 72 the other side. That's how I wrote. Today I'm writing them in the column. Less than root 72, these are the factors. What about the more than root 72? Now think about it. Hey, how did I ask you to write yesterday there? Yesterday we said that, hey, 1 into something is 72. What is the other side of the spectrum therefore? 72. 72 is one of the factors. 72 is there, 2 into something will be equal to 72. What is that? 36. Because the number of numbers on this side has to match with the number in the other column. There is always a matching there, right? There is always going to be a matching there. Good. Okay, therefore 3 on one side, and you have to write another number so that the product becomes 72 once again. Yeah, what is that? 24. Okay, now 4 into something, right? So 4 into something would become 72 once again. What is that? 18. Similarly, there is a 6 and something. What is that? 12. Right, then 8 and something. What is that? 9. Good. All right, you wrote them. So how did I develop them? Think about this. 1 into 72 is 72. 3 into 26 is 72. 3 into 24 is 72. 4 into 18 is 72. 6 into 12 is 72. 8 into 9 is 72. Simple. So therefore, what is this? What is this whole game here? Simple here. If I were to write a number as a product of two factors, number of ways of writing a number as a product of two factors is nothing but total number of factors of the number, right? This is nothing but total number of factors of the number divided by 2. Why divided by 2? You have 6 factors on this side, you have 6 factors on this side. 72 has 12 factors. 12 factors divided by 2 is nothing but number of ways of writing it as a product of two factors. There is no order. Now don't say that, okay sir, 1 into 72 is different from 72 into 1. There is no order. It's a product of two factors. I'm simply calling them as F1 into F2. It's easy. F1 greater than F2 or F2 greater than F1. Nothing like that. There is no order to it, right? Yeah. So therefore that is the point there. Number of factors divided by 2, right? That's a point, because we know that here there are 12 factors and there would be 6 pairs. Now how do I develop this? So mathematically, if I know that 72 is nothing but 2 raised to power 3 into 3 raised to power 2, number of factors, 3 can be permuted in 4 ways, this 2 can be permuted in 3 ways, 4 into 3, 12 factors. You know, quickly said that, okay sir, 72 has 12 factors, 12 divided by 2 is equal to 6. That's how the maths would have looked on this particular question. I don't have to keep generating this, but why did I generate this? So that you can visualize it. Hereafter you can visualize, okay, there will be 2 columns, there is one set of numbers in one column, another set of numbers in another column. We got to get the pairs, logical pairs out of these particular set of numbers. Great. All right, so that's about this particular premise, right? Yeah, let's come back to this original question there. Okay, what is this question talking about? What is it talking about? It says that, hey, there is 360 can be written as a product of 2 factors in how many ways? Firstly, all right, look at this 360, apply the fundamental theorem of arithmetic, FTA or FP, all right, FPA, apply the theorem on this. So what is this 360? 360, okay, 36. 36 is nothing but 2 raised to power 2 into 3 raised to power 2. A 10 is nothing but 2 into 5, right? 2 into 5. Put them together, 2 raised to power 2 and 2 raised to power 1. You say that, hey, this is 2 raised to power 3, right? 2 raised to power 3, 3 raised to power 2 into 5 raised to power 1, like this, right? Now, with certain amount of understanding and experience, don't worry, you will look at this and you will start writing this. No big deal about it, all right? This can happen in the mind, not happening in the mind, you can do it on a piece of paper. No worries on that, right? You get this 360. Now, product of 2 factors. Find the total number of factors. Therefore, first you find the total number of factors. 2 power 3 permuted in 4 ways. 3 power 2 I can permute it in 3 ways. 5 power 1 I can permute it in 2 ways, right? This is the total number of factors. Total number of factors divided by 2. I will not multiply them. I will divide it and tell the answer. This is the total number of factors. 4 into 3 into 2. Of course, no big deal. It's 24. So out of 24, you say that, okay, 24 divided by this, which is 12 ways. In the sense, this can be represented as a product of 2 factors in 12 ways. It's nothing but counting business. Basically, we are actually trying to count the factors, but this time it's going to be the pair of factors. Point number 1, right? This is point number 1. Let's come to the second point from here. I hope you are getting this. All right, you are getting this, what I'm trying to say. Second point. Let's come to the second point. Under the product itself, there are 3 points under the product. I made the first point there, so I will go to the second point, then I will go to the third point, then we are done with today's lecture. Right, so here come to the second point. In how many ways 360 can be written? This is done, right? In how many ways 144 can be written as a product of 2 factors? All right, 144 to be written as a product of 2 factors. Let's try and take a look at this here. What is this 144? 144 is nothing but 12 square, right? 144 is nothing but 12 square. That's how it comes to mind. Okay, what do you mean by 12 square? 2 power 2 into 3 power 1 whole square, right? That is 12 square. Nothing but 2 raised to power 4 into 3 raised to power 2. That is 144. Don't worry how to write it like this. All right, this is just a matter of time. You will get that. It's a very simple art, right? It's a very simple technique, no big deal. All right, so you got this 144 is equal to 2 raised to power 4 into 3 raised to power 2. All right, so therefore how many factors are there for this particular 144? Therefore factors of 144. Factors of 144 is 5, and here you say it is 3. Therefore factors of 144 is 15. Therefore 144 can be written as a product of 2 numbers, right? Product of 2 numbers in how many ways? Total number of factors divided by 2. You say that 7.5 ways. Looks absurd, right? This is absurd because you generally heard that you can do it in 1 way, 2 way, 3 way. Nobody ever said that you can do it in 2.5 ways, 2 quarter ways. Hey, you never came across like this in the counting. So whenever you count, you say that there are 2 ways to do it, there are 3 ways to do it, there are 4 ways to do it. You never said that there is 4.5 ways to do it. Oh, there is nothing like that, right? But then you got an absurd answer. Here, man, 7.5 ways. How can this be, right? 7.5 ways. Fairly understood, right? No, that is not the answer. See here, there a word distinct. How many ways 144 can be written as a product of 2 factors? There is no distinct, which means I can write this as 144 can also be written as 12 into 12. I can write it as 12 into 12 also, because it's not 2 distinct factors. Can I use the same factor twice? Is 12 a factor of 144? Yes. Is the 12 a factor of 144? Yes. But the point is 12 should be written only one time. But when it is a product of 2 factors, duplications are fine. fine. You can consider duplication once. 12 into 12 is one way of writing. So which implies what? You are duplicating a factor. If you are duplicating a factor, in this case what you do is, when you know it has odd number of factors, because 144 is a perfect square would have odd number of factors. An odd number will not be divisible by 2. Add 1 and divide by 2. Add 1 and divide by 2. So thereby it becomes 8 ways. Alright, thereby it becomes 8 ways. Hey, let me tell you this. Okay, on one side, let us write the factors less than or equal to 12. Less than or equal to 12. You may wonder, sir, why less than or equal to 12? What is the square root of 144? 12, right? Less than or equal to 12. Let us write it. Does 1 divide 144? Yes. 2, yes. 3, yes. 4, yes. 5, no. 6, yes. 7, no. 8, yes. 9, yes. 10, no. 11, no. 12, yes. Right? So you wrote all this particular list. Now write the numbers on the other side of the list. Let us write the numbers on the other side of the list. What is the other side of the list? Other side of the list is greater than 12. Factors which are greater than 12. Okay, so this is 144. All right, this is going to be 72. Right, and this is going to be 48. This is going to be 48, and this is going to be 36. Right, going to be 36. The next number is going to be next number is 24. 24 into 6. Then 18 into 8 is 144. Right, then you say that 12 into 9. Then you say 16 into 9. Then you will say, now this is over. That's it. These are the 15 factors. Did I write 15 factors here? Yeah, I wrote 15 factors here, right? So 1, 2, 3, 4, 5, 6, 7, 8, then 9, 10, 11, 12, 13, 14, 15. These are the 15 factors, because you said that the given number has 15 factors. I wrote all the 15 factors, right? So this is one way. This is the second way. This is the third way. This is the fourth way. This is the fifth way. This is the sixth way. This is the seventh way. You wrote only 112 there. Therefore, you got the earlier answer as 7.5. But there is nothing called as 7.5 ways of doing this. Therefore, what you said, you duplicated. You said that, okay, let me complete this fill in the blanks. You said that I will take another 12. For this 12, you use this one extra bonus factor. Bonus factor means what? There is an existing factor which I am going to use once more, right? So I am going to use it once more, which becomes a bonus factor. Divide by 2. Now it becomes 8 ways. In the sense, what I am trying to say, if the given number, okay, earlier, so there are two things we already discussed. If the given number is not a perfect square, then the number of ways of writing the given number as a product of two numbers is the factors of the number divided by 2. In case if the given number is a perfect square, then the number of ways of writing the given number as a product of two factors is the factors of the number plus 1 divided by 2. What is this plus 1? The bonus factor. One of the factors you are going to repeat. That's a bonus factor, right? Fair enough? All right. Now look at the same question. How does it come here? You may say that it's the same question, right? Yeah, it's the same question, but one added word, right? In how many ways 144 can be written as a product of two distinct factors, right? As a product of two distinct factors. All right, two distinct factors, which means what? Let me go back to my previous slide. So here, here I just used two distinct factors. I introduced the word here, two distinct factors. If it's a distinct factors, this has gone out. 12 cannot be used. 12 into 12 cannot be used. Now, how do I get this? Hey, you had 15 factors in the beginning. This fellow has no pair. Discard this fellow. Distinct factors, which is 1 and 44 are distinct. 2 into 72 are distinct. But when you wrote here 12 into 12, they were not distinct. They were same numbers, right? But then this time when I say that, hey, I want the product of two distinct factors. Simple. In that case, if the given number, next point here under this, if the given number is a perfect square, but if you were to write the number as a product of two distinct factors, that is f1 not equal to f2, product of two distinct factors, then you would say that, hey, it is total number of factors minus 1 divided by 2. What is this minus 1 for? Discard this fellow who does not have a pairing, right? There is one number 12 here who does not have a pairing. Discard that particular fellow. Guys, all right, from today's learning, so we kind of learned that. Okay, what is that we kind of learned today? We learned, all right, now how to deal with the factors. There is a total sample space, From there, we look at the active and the passive sample space, right? Yeah, there is an active space and there is a passive space. It is not that all the questions are going to be constructed on the total sample space. You need to understand that what is the active space on that and start working on that active space. That is number one. Second one, we looked at one of the applications. Now that I know how to count my factors, what can be some of the other things I would have learned in the high school? So this is another thing that you learned there, which is number of ways of writing the given number as a product of two factors that we kind of learned there, right? Okay, so let's put this to perspective. Now these are the two elements you kind of learned there, right? These are the two elements you kind of learned there. Okay, you can take this particular question as a homework, which I will explain in one of my next classes. Or you want me to do it now? So we will do this together. Not a worry. Quickly take a look at this. Take a look at this. What is that extra thing coming there? Because we looked at 360. Of course, we looked at this 360, no doubt. How many ways 360 can be written as a product of? But then there is a word here. How many ways you can write this as a product of two coprime factors, right? Two coprime factors. First, let me quickly explain. Let me take 72, just like we did before. Let me take 72. We said that, okay, 1, 2, 3, 4, 6. And 8, then 8 into 9, right? 8 into 9. Then we said that, okay, 12 into 6, 18 into 4, 24 into 3, 36 into 2, and 72 into 1. What do you mean by coprimes? The two factors are said to be coprimes, F1 and F2. Two factors are said to be coprimes if their HCF is going to be 1. Right? If their HCF is going to be 1. In the sense, now I got to look here. Here I got to look at HCF of 1, 72. Hey, is this 1? Yes, it is 1. Therefore, this is the coprime pair. This is a coprime pair. Okay, next one. A HCF of 2, 36. One side I have 2, another side I have 36. What is the HCF? 2. Therefore, is this a coprime pair? No. 2, 36 is not a coprime pair. Alright. What about here? HCF of 3, 24. What is this? The HCF is nothing but 3. Therefore, 3, 24 is not a coprime pair. This is not a coprime pair. Right. What about 4, 18? 2 is the HCF. Therefore, it is not a coprime pair. What about 6 and 12? 6 is the HCF. Alright. Therefore, this is not a coprime pair. There is a 6 HCF here. Right, 4, 2 is the HCF here. Therefore, they are not the coprime pairs. What about 8 and 9? Yes, it's a coprime pair because the HCF of 8 and 9 is 1. HCF of 8 and 9 is 1. Therefore, that is the coprime pair. Fair enough. Okay, therefore, you said that, hey, all those 72 can be written, as a product of two factors in 6 ways. This is 1, 2, 3, 4, 5, 6. So, 72 can be written as a product of two factors. Simply product of two factors in 6 ways. However, 72 can be written as a product of two coprime factors. This F1 and F2 are coprimes, right? Product of two coprime factors in 2 ways, which means it is going to be a subset of this, right? It's going to be a subset of this. How do I get this? All right, now how do I get this is this. If the given number is represented as a prime 1 raised to power A, prime 2 raised to power B, and prime 3 raised to power C, etc. Then the number of ways of writing the given number as a product of two coprime factors. Number of ways of writing the given number as a product of two coprime factors is 2 raised to power number of prime factors, 2 raised to power number of prime factors divided by 2. Just like in the previous slides. If you look at the previous slides, say there is always divided by 2, right? There is a divided by 2, there is a divided by 2, there is a divided by 2. In the sense, I need the pairs for sure. But how do I look at the pairs is a different issue. But this is how you look at the pairs this time. So what is that? You have to consider 2 raised to power number of prime factors divided by 2. Half of it. Alright. So what does it mean to us? Take a look at this 72. Let me come back to this 72 for a while. 72 is nothing but 2 raised to power 3 into 3 raised to power 2. Hey, what are the prime factors? What are the prime factors of 72? Only 2. 2 is a prime factor and 3 is a prime factor. That is it. There are only 2 prime factors for 72. Therefore, the answer for 72 is 2 raised to power 2 divided by 2. What is 2 raised to power 2? Because there are only 2 prime factors. 2 raised to power 2 is 4. 4 divided by 2. There are only 2 ways. Hey, which are those 2 ways? I boxed it here, right? So 1 into 72 is one way. 8 into 9 is the second way. Okay, we'll understand little more about this, sir. Why why did we take 2 raised to power prime factors? We will do this, we will revisit this concept when we do the basics of permutation and combination, right? We will do the basics of permutation. I will teach little more about the fundamental principle of counting. We will talk about it at that particular stage there, right? We will talk about at that particular stage. In other words, it's also very simple there. Hey, what is that? Is nothing but simply this. You have to take this entire thing as one lot, this whole stuff as one lot, and this whole stuff as one lot. Simple. Therefore, this one can be permuted in 2 ways. This one can be permuted in 2 ways. If you want to just quickly give us a hint, this entire 2 power 3 should be treated as one lot. This entire 3 power 2 should be treated as one lot. I cannot distinguish. It should be treated as a lot, entity, complete entity. 2 into 2, that is the 4 that you read there. Totally, there are 4 ways of dealing with this. Divide by 2. The 4 divided by 2 becomes my answer. All right. Now let me come back to the given question. On this note, let me come back to the given question. Okay, what does the question state? 360. We already examined what is this 360, right? We examined 360. This is 2 raised to power, this is nothing but 2 raised to power 3 and 3 raised to power 2 into 5 raised to power 1. Right, this is what we meant by 360, right? Yeah. So from here, now you will say that, hey, how many prime factors there? If you want to understand one way of dealing with this, a number of prime factors, there are only 3 prime factors. Which are they? 2 is a prime factor, 3 is a prime factor, 5 is a prime factor. There are 3 prime factors. Therefore, number of ways of writing 360 as a product of 2 co-prime factors, F1 into F2. The F1 and F2 should be co-prime factors. Writing it as a product of 2 co-prime factors, you would say that 2 raised to power 3, because there are 3 prime factors, divided by 2. What is 2 raised to power 3? 8. What is 8 divided by 2? 4 ways, right? So 360 can be written as a product of 2 co-prime factors in 4 ways. Other way of looking at this, as I just quickly said there, you say that, hey, this whole thing I will call it as one entity. This whole thing I will call it as one entity. This whole thing I will call it as one entity. Therefore, this one can be permuted in 2 ways. This one can be permuted in 2 ways. This one can be permuted in 2 ways. What is 2 into 2 into 2? 8. That is the same 8 you captured here. 8 divided by 2, which becomes 4 ways. Now, why I should take this entire bunch as one entity? We will get that clarity when we do the permutations and combinations, right? We will do that then. Okay, if you have still some doubts, right, whether you are watching it online live or whether you are watching it later stage after the live, doesn't matter. If you still have certain doubts, you can always reach out to me on this particular Telegram channel. You can post your concern there, you can post your doubts there, or whichever way, right? Either I will help you, or there may be some other peer groups which will try and help you there. So so you can, not only that, if you have any counseling needs or certain short things that you would like to convey to me, you can always do that. Not only that, even in that video you will have that comment section. You can go there and you can put your comments there. I will also come and answer some of your comments there. I will read and watch and answer some of your comments. Yeah, if you have liked it, so you can always press the like button before you leave this particular lecture. At any stage you liked something there, you can always express that to me, so that I'll get to know that, okay, somebody is getting benefited out of this particular lecture. Thank you for being here. It was wonderful here. So you can subscribe and you can press on the bell icon, so that whenever I start a lecture, you kind of get to know about it and you don't have to miss, and you can interact with me there. All right, that's pretty much about it. I hope you guys had wonderful learning with respect to some of the basic elementary ways of looking at the factors, and one application, that is number of ways of expressing the given number as a product of 2 factors. All right, guys, I will see you in my next lecture. That's tomorrow. So bye till then. Stay blessed. God bless you. God bless you. God bless you.